So what does friction do? Opposes the motion. Which motion? Relative motion. Friction opposes the relative motion between two surfaces. If you see this block, if I apply a force F, this is the external force. If I am pulling it towards right side, what will happen? There will be a relative motion between the block surface and the ground. What is the meaning of relative surface? That there is a difference in the velocity. Ground ka surface is at rest. This block will have a velocity due to this force. So due to the relative motion between the block and ground, this friction will arise, and this friction will say that, boss, I will oppose it. I will not let you move. Check it. The friction doesn't oppose the motion. The correct term is friction opposes the relative motion between two surfaces. Remember this. So friction is denoted by small f. Now mainly two types of friction are there. One is static, one is kinetic. Focus on the name. Static and kinetic. What is the meaning of static? At rest. Kinetic means something which is in motion. Okay. So the moment object is not moving, you are applying the force, but still it is not moving. So which friction will act? Static. Now when you're applying the force and still friction exists, object is moving. Okay. In the second case, you applied this force, object is moving, still friction will be there. And that friction when object is moving is called kinetic friction. So always focus on the name. It is self-explanatory. You don't have to mug up anything. Static friction will act when object is not moving. Kinetic friction will act when object is moving. When you are walking or running, which friction is acting? Kinetic. Check. You are pushing, suppose you are shifting to a new place, right? And you are helping your parents. Suppose you have a very big sofa or dining table and you are trying to push it, but it is not moving. Which friction is there? Static. Okay. The friction is there. When you are writing on the notebook, movement is there. What is the friction? Kinetic. Okay. Many examples, you know all the examples. The moment, suppose this thing. Have you heard of this word called slipping or sliding? Right? Heard of this? Right? Sliding or skidding or slipping. So suppose you slip on the ground. Let's assume that you would have seen in movies or serials, and they slip and they start flying in the air. Okay? And then there is a background music. So what happens? Oil, okay, or water. So what does oil and water does? Reduces the friction because friction is required for a controlled motion. If you're walking smoothly means you're walking in a controlled way. If you want to move in the forward direction, you're moving in the forward direction. It's not like that you slip and move in the left direction, right? So when you slip, what happens? The friction between your foot and the ground surface is reduced because of oil or water or any slippery surface. Okay. So friction is required for controlled motion because we always think that friction is something which is unwanted. No. In some cases, friction helps. In some cases, friction opposes. Okay. You see that I have written one more term here. Static friction is self-adjusting. Anyone knows the meaning? What is the meaning of this word? Static friction is self-adjusting. Anyone in the class? What is the meaning of self-adjusting?
It doesn't have a
I will
fixed
give.
value.
Yes, Aditi. Can you repeat yourself?
It doesn't have a fixed value.
It doesn't have a fixed value. Okay. So how is it called self-adjusting then?
Like it has a maximum value, and any value below the maximum value, it will like adjust itself accordingly.
Adjusted. Correct. So understand that there is no formula for static friction. The formula we have for static friction is for maximum static friction. There is no formula for static. You cannot calculate static friction by using a formula, but you can calculate Fs max. Okay, it's like suppose in your bank account there is 1 lakh rupees. Okay, you have 1 lakh rupees. Is it necessary that you have to spend everything? That is a maximum balance. Whatever you want, you use it. So what is the purpose of static friction? To stop the object. So if I am applying a force of 30 Newton, how much force is required to stop? 30 in the opposite direction. Correct? And let us assume that maximum static friction is 50. The maximum static friction is 50, but you need how much to stop? 30. Now suppose you apply a force of 40. How much you need to stop? 40. You will not use maximum, right? Whatever is required, you will use it. That is the meaning of term called self-adjusting. So whatever external force I applied, same value static friction will take in the opposite direction. To which case? To this value. Because this is a maximum. If you apply a force greater than maximum static friction, then what will happen? Object will start moving. Before that, object will not move, and static friction will be same as the force. That is the meaning of word called self-adjusting. And when will object start sliding? Sliding means moving. When the force what you're applying is greater than maximum static friction. The moment you apply a force greater than Fs max, the object will start moving. And the moment object start moving, which friction will come into picture? Kinetic. This is the story of friction. If you understood this, you can approach any question. Problem what happens here, most of us are not able to understand the difference between them. Okay. Clear? Anyone writing anything? Take coffee quickly. Why you guys are waiting? I'm repeating again, there is no formula for static friction. There is no formula for static friction. Formula is only for maximum static friction and kinetic friction. Static friction is self-adjusting. Whatever force you apply, static friction becomes the same thing in the opposite direction. Huh? Studied this in PE. The syllabus has changed. You guys have yoga also in PE. Yoga, yoga hardest. Cricket, cricket, cricket is not there. Olympics, Olympic. I studied yoga Olympics in bus when I was going to the center because the book what I had was a 5 to 6 years old edition. I didn't buy PE book till my final exam. So when I went to the bookstore, that uncle says that ki, are you mad? After 2 days you have PE exam and you are coming for asking the books. I asked all my friends. They told that bhai I will not give. We have exam. None of them gave me the textbook. And I took the book from this kabaddi wala person who sells the on the road that second hand book. So I bought it for 8 or 10 rupees. I studied. I was very happy that I finished everything in one day. And when I'm going in the bus to the center, my friend says that you study yoga. It's very tough. I open the book and see there's no chapter called yoga in my textbook. Then he asks cricket. Then he says Olympic cricket, though it's manageable. Those two chapters I studied in the bus, and 9 marks came from there. PE, most of us don't consider as a subject, but and I got highest in PE only. PE saved me. Okay, chalo, copy it. Done. When is computer exam? Second. Manjeet, you are getting highest in physics. Okay. All of you see here. Draw the diagram quickly. It's a simple question. Just quickly discuss it. So there are four values of F. four values of F. There are four values of F. You need to find the acceleration. You need to calculate acceleration and static friction in each case. Question is, find the acceleration and static friction in each case. Find the acceleration and static friction in each case. So what is the formula for Fs max? Fs max is called F limiting also. Don't get confused in the exam. Fs max or F limiting is same. What is the formula? Mu s into n. N is the normal force. So if I draw the free body diagram, what will act in the downward direction? Weight. So 10 into 10, 100. What will act in the upward direction? Normal or reaction force. If you apply a force in the right direction, the tendency to oppose the motion, friction will oppose the motion, so friction should be in backward direction, left. Friction is always denoted by small f. Okay, that is the sign. Now, until and unless it moves, which friction will be acting? Static. And the moment up to which static friction acts, what will be the acceleration? Zero. Because object is not moving. The moment this F is greater than Fs max, it will start moving. And which friction will act? Kinetic. So you guys know the concept. Solve all the parts. Tell me the answer quickly. So first let's find Fs max. Mu s is 0.5. Normal will be balancing the weight. So this is how much? 15 newtons. So in the first case, will the object move? No. Acceleration will be 0 and F of S will be how much? What will be static friction? 20. I told the statement static friction is self-adjusting. If it is 20 here, how much force you need in the opposite direction to stop? 20. Or you can say just greater than 20, 20.00001. But approximately it is 20. 30. Less than Fs max. Will the object move? No. So what will be static friction? Same as 30. Now what is the external force? 48. Is it less than 50 or more than? Less. Will the object move? And what will be static friction? 48. Now fourth case. The external force is greater than Fs max. Will the object move? Find the acceleration quickly. All of you. Acceleration is 1.8. 1.2. Okay, noted. All of you find the acceleration in the last case. Really done? Any other value for acceleration? Any student?
So is it 10?
10. No. Any other
So
value?
5.2.
5.2.
So
Okay.
when force is equal to ma only we'll use here, right?
Force is ma. Yeah, basic formula for force is ma. Any other answer? I got 5.2 and 1.2. Any other answer? Why only few students are getting the answer for this one? This is simple thing. We don't even have to use pen for this. I got one correct answer already, and you solved very quickly also. Very good. Once you have understood the concept, these things should be on your fingertips. What is the force? 52. 52 is greater than Fs max. Will the object move? Yes. Once the object starts moving, which friction acts? Kinetic. So if you draw the diagram, which force will act? F, and here it will be F, K, and it will move like this. So what will be the acceleration? Yesterday we discussed driving force divided by total mass. What is the driving force? F minus Fk divided by mass. Any problem? So what is force? 52. What will be kinetic friction? Mu k into n. So 0.4 into 100 will be how much? 40 divided by 10. So 12 by 10, 1.2 meter per second square. What's difficult in this? You guys know everything. Where's the revising grade 12 portion? It doesn't mean that we are doing grade 11, so you forget grade 12. Parallelly, you have to study grade 12 every day. Divide your time into two equal parts, 11th, 12th, 11th, 12th. This 1.5 month, if you remain focused, life will change. And if you don't remain focused, still life will change. Okay? So what change you want, you decide. Okay. Done? So let's move to the next question. In college, we had a very young professor, lecturer. He was 39 or 40. He retired. He retired from the job. He started teaching. He told that I have that much money that if I don't work also for 20 years, I can sit at home and relax. He was working in US and he retired. So he used to just teach only for 3-4 hours every day. We had a subject called computer networks. So he used to teach that. And he used to be very much chilled out. If you come late to his class, still you will get the attendance. The only thing is that you have to bring something for him to eat. There was a condition. If you come late, he will just say that you want attendance. If you say yes, he will just say bring one coffee for me. Anything to eat from the canteen. Okay. And he only put my paper on the notice board. Basically, there was a question of there is a concept called computer science students. You will learn this concept called bucket leaking in computer networking. Basically, when information gets leaked from a pipeline. Who has SQL? Have you guys heard of how to create a pipeline? You learn in first year of college. So there is a concept called bucket leaking. Data basically gets leaked. So me and my friend basically draw a water tap and bucket and the water was leaking. Okay. We just did musti and we drew. He took the Xerox and put that paper in the magnified, full everything, my name, my roll number on the notice board. So my friends call me and says that, dude, you're famous in the college. Your professor put your paper in the whole college on the notice board. Only my face was not there, so I was safe. Okay, so don't do these things in college. If you feel that you are the boss, few lecturers are there who are far thug life than you. Okay, you will not realize what can happen to you. Chalo, let's discuss this graph. So this graph is simple. What is this F? The force applied, external force. Okay, and this is the friction. So this is the graph between friction and the external force. If you remember, we discussed one statement to Fs max. What happens? If F is increasing, static friction is also increasing. Basically, both are equal. So can we say y and x are equal to Fs max? So if y and x are same, what will be the graph? y equal to x. See this graph. And you see that this line, y equal to x. So this much, this region will be called what? Static region. Okay, you need to understand the graph, no need to mug up. This graph has proper explanation. So up to Fs max, you know that F and static friction both are same. So y is equal to x, straight line. After that, you can see there is a dip in the graph. Why there is a dip in the graph? Because mu s is always greater than mu k. So can I say that Fs max will be always greater than Fk? Correct? So that is the reason there is a dip in the graph. So this much region will be which region? And kinetic friction is fixed. It is not self-adjusting. Okay, kinetic friction is fixed. That's why the graph is a constant graph. Done? Remove it. Any doubt in the graph? Anyone?
So 1 second.
1 second. Draw it, draw it. This much part is static and this much part is kinetic.
Oh yes, yes.
Done? Anyone else drawing any part? Any doubt? All of you solve this question quickly. 30 seconds or maximum 1 minute, not more than that. Find out the answer for this.
So is it 6?
6. Okay. Good. What one answer is 6. Any other answer?
So 6.
6. Okay. You got 7.6. Okay. Okay. So I got two answers. One answer I got a 6. Other is 7.6. Okay. Any other answer? Four. Okay. You got 4. We'll add 4 also. Any other answer? 4, 6, 7.6. Okay. Yes. Saket, how did you solve it? You took entire thing as system. Very good. Total mass is 25. Very good. 250. Fine. Very good. Excellent. Very good. So we'll take this as system. You can consider this as a single box. So it will be a single box of how much mass? 150. Okay, so you can draw the system again. 150. 150 or 24? I saw one. I saw. See, that is 25. So what will be the weight? 250. And what will be the normal? So N will be equal to how much? 250. You will apply a force of 200. So friction will be in which direction? Left or right?
Left.
So this is the friction. So since they're asking acceleration, it means object is moving. So by default, it means it has to be kinetic friction. Sometimes they intentionally give mu s and mu k both. So you need to understand that if object is moving, you have to use mu k. If object is at rest, then you have to use mu s. So acceleration is net force. So 200 minus Fk divided by, what is the total mass? 25. So 200 minus 0.2 into 250 divided by 25. So all of you solve it, you will get the answer. So when you solve this, this is coming 150, 200 minus. Any doubt in the question? Simple problem, nothing difficult. Anyone writing? Should you move ahead? If we attach one more block to that, will the method change? Method will be same. Solve the next one.
So 0.06.
So I got one answer as 0.06.
So sorry,
0.03 option.
0.033.
0.03. Option 2. Okay, noted.
So option 2.
Option 2. Okay. Okay, okay, let's check. A marble block of mass 4 kg lying, stop talking. I'm explaining. See, a marble block of 4 kg lying on ice when given a velocity of this is stopped by friction in 20 seconds. So it's stopped by friction in 20 seconds. We have time, we have velocity. Okay. So what is the first thing we need to find out here? Acceleration. So see, force which is stopping this, correct, will be same as what? Friction. Friction is stopping it. So can I say that MA will be equal to friction, which is mu into N, and will be equal to how much in this case? Weight of the object. Okay, if an object is lying on a horizontal surface, what is normal equal to weight? So the friction will be equal to what? Stopping force. Ma is the stopping force. So A will be equal to how much? Mu into G. Okay. So V equal to U plus AT. So if it is lying on the ice, when given a velocity is stopped, so what will be the final velocity? 0, because it is stopped. What is the initial velocity? 6. What is acceleration? Mu into G is 10. And what is the time? 20. So this will be how much? 200. So mu will be equal to minus 6 by 200, which is minus 3 by 100, which is minus 0.0. Why? It is 0. Sorry, minus. What is the mistake? Why it is coming minus? What is the mistake I have done? Direction. Acceleration you have to take as negative here because it is stopping. So that acceleration is opposing the motion. So I have taken the magnitude here. So don't get
Sir, how did
confused.
you get? So, oh, okay. So what?
So all of you don't get confused that how come coefficient of static friction is negative. It is coming negative because here I just took the magnitude. I didn't take the sign. Okay? So if you are getting confused, you can take the acceleration as what? Negative. All of you are
So
clear
how
why
did you get
acceleration?
200?
How did I get 200?
No, I didn't. I was solving it and I got it wrong, so I didn't see what you did.
Acceleration is mu into G. Okay?
Yes, sir.
Substitute here. So G is 10, time is 20, 10 into 20, 100.
Okay.
Okay, so acceleration will be negative if you take the proper sign. So when you take the acceleration negative, this will automatically come positive. I just took the magnitude, that's why answer is coming. I'm repeating again why this is negative because we are stopping. So acceleration will oppose the motion. Done? Simple. Anything difficult in this? Okay. One thing, remember that whenever you see a new question, don't keep on thinking. I see that some of you keep on thinking but don't write. Start putting it on the paper. Draw a figure for this. There is a block. It is being stopped. So friction will be same as the stopping force. So you can calculate acceleration. Once you start putting your thoughts on the paper, you get more idea. So don't keep on thinking. And it will start happening when you solve more questions. That is the key. That is the main problem with physics, that we understand everything in class. Correct? But when the time of solving the question comes, why does it happen? Because more practice is required. That's it. Okay, all good. Why are you crying? There is nothing wrong. If you, until unless he is laughing, it's fine. You need checkup when he starts crying. All of you draw this figure. No need to ask for emergency situations. Like, so this is the diagram given. We have two blocks and we have applied an external force on the upper block. Okay. The ground is smooth, means there is no friction. But there is friction between A and B. In the question, you can write down the surface between A and B is rough, means friction is present here. This we have taken as smooth. So question is find, write down the question, find the force F, find the force F such that there is no sliding between A and B, or You can say both the blocks move together. There is friction here. So this is a rough surface. This question is very common in your NEET exam, JEE exam, BITS exam. Very commonly asked. It is applied on A, it's written, right? Second part is ulta. It is applied on B. Okay. So this is a very common question. Let's discuss this. We'll draw the free body diagram first. So all of you understood the meaning of the question, that there is no sliding, means both of them are moving together. So this question can be asked in two ways. Either there is no sliding or both the blocks move together. So if both the blocks move together, will they have common acceleration? Yes. Let's find the common acceleration. So common acceleration will be net force divided by total mass. So I'm taking this as small m, this as capital M. Now we will draw the free body diagram. On block A, where will the friction act? Left. So if they are moving, it means it will be kinetic friction. On B, friction will act in which direction on B? Left or right? Huh? Who said right? Anyone said right? Huh? Manoj?
It'll be on left, right? Because it's opposite.
Okay. Who all are for left? All of you tell me. Who all think that friction on B should be left? Who all are telling left?
So then isn't that a smooth surface though?
I'm not
So
asking ground. Top, on the top I'm asking.
Okay.
Left? All of you are in the left team? Left wing, right wing? Which wing? Left? Anyone for right? Okay.
It's
One
right
student.
side. So it's
Right side. Right. Right. Take. Right is right here. Okay. Right is the right answer. Let's understand why. All of you see on the board. If you see the common surface between A and B, okay, if this is action, reaction will be in which direction? Opposite. There are multiple methods to understand this. I will explain by two methods. Whatever suits you, you can remember that. Okay. So between A and B, we have this force. So if this force is the action, reaction should be equal and opposite. So the reaction will be in which direction? Any problem? Pakka? Check. If you feel that I'm not comfortable, you should be comfortable. But if you're still not comfortable, there's one more thing. This object will try to maintain its inertia. Inertia of what? Inertia of rest. Because the force is directly applied on A. Our common sense says, forget about physics, common sense says that, sir, if you apply the force on A, how come the B will move? A should move and B should remain at the same place. But why B will move together? Because A and B have enough friction. Understand that? If they don't have enough friction, it's common sense that if I apply force on A will move, B will be at rest. Because there is enough friction, the friction between A and B will say that, boss, I will also move you along with. So the friction will basically move it in which direction? Forward. Friction on B, not friction on A. Friction on B. So inertia of rest says that remain at rest. But what is the meaning of friction? Oppose the existing state or oppose the motion. So what is the initial state of this? Rest. So friction will try to move it. Till now we have heard that friction will try to stop it or control it. Here also friction is only controlling because friction is responsible for moving this. So inertia of rest will make sure that it remains at rest. Friction will oppose it. So friction will move in the forward direction. Okay, second thing, I don't get convinced much, so I always follow the first method, action and reaction thing. That makes more sense. Anyone having doubt? Anyone still feel that
Suppose the
friction
three
should?
blocks, then is there?
Yes, Ashank, tell me.
So if there's suppose three blocks, right? Then the will they continuously be opposing, or I mean, in a sense, if I put another block on top as C,
Hmm.
and I have to move all three, and between each block there is friction, and the same case.
So
So
for the center block, for the center one, there will be two frictions.
okay, fine, yeah.
One because of top, one because of bottom. Okay, any problem? Clear? Now, tell me which force is responsible for moving this one. Take friction. You may say, sir, this. Yesterday I told, in free body diagram, we always consider which force which is directly acting on the object. F is not directly on B. If you see the free body diagram, which force is responsible for the movement of B? F. So can I say that this F will be equal to mass of B into the common acceleration? Any problem? We know that there is a definition for friction. Friction is basically mu into N. But I'm thinking in a different way, that this force is responsible for the movement. So by the basic definition of force, force says what? Force is equal to mass into acceleration. Why common acceleration? Because that's what I'm assuming, that both of them are moving together. Clear? Now, if both of them are moving together, this force should be less than Fs max or greater than Fs max. I'm repeating again. If there is no sliding, correct? Moving together means what? No sliding. So the force should be greater than Fs max or less than Fs max? Less. Less. Because the moment it is greater than Fs max, there is a sliding. Here it is written that, boss, I don't want any sliding. I want them to move together. So if this force is moving it, this force should be less than Fs max. There is not a single point which you need to mug up if you understand each and every point. So this force should be less than Fs max. Anyone having doubt in this? Why? Anyone in the class? Because I don't want any sliding. And this is a force which is responsible for moving this. Now, MB. What is A common? We found, right? F divided by. So we are taking small m and capital. I will write MB and MA. Did I write ulta? Mass is capital M and small m. I change it. For B, what is the mass we took? Capital, right? Capital M. Okay. Now the friction is acting between these two surfaces. So what will be normal? What will be the normal? So normal will be equal. And then find the value of F.
Sorry, you're on mute.
Audible now?
Yes, sir.
Yes, sir.
Now calculate F.
So,
Yeah.
why do we consider the normal reaction on A and not the normal reaction on B?
Why not the normal reaction on B? This
Why is
weight
that?
is acting on B only, na?
Okay.
When you join them, see here, the weight of A is acting on B. And who is
Yes.
balancing that? The normal by B. We need to find the normal between A and B because the friction is between A and B. So that's why you have to take the mass of A.
Okay, sir.
Any other doubt?
What if the force was acting
Ah,
on B?
so that's what is the next case.
Okay, fine.
That's what is the next case. So what will be F from here? If I rearrange the term, F will be less than or equal to mu s into small mg into small m plus capital M divided by capital M. Done?
So, do the masses of the blocks matter? Like, suppose if A was lighter than B, then would they
Those
still
things,
move
yeah.
together?
See, there are multiple cases in this then. Okay, there can be infinite number of cases in this. So we take the case in such that the friction is enough to move them together. Okay, if you take this object is very lighter as compared to this, then what will happen? It will get dragged. You have to choose the mass properly. That calculation is also done.
Okay, sir.
Just check the method. Anyone having doubt in anything? All clear? Pakka? Stop it. This direct question comes. Direct. You can, if you have uh, any JEE mains or BITSAT book, you will find that, or the NEET exam, you will see that they directly ask, tell me the force with which I should pull it so that both of them move together. You need to know the calculation. And if you see the calculation is hardly of how many lines? 1, 2, 3. Within 3 lines. If you know the concept, you can solve it within 30, 40 or 45 seconds. If you know it how to approach. There is not much calculation in this. Any doubt? All clear? Now, in this, let's modify the question. The question is, if sliding is happening, question is, if sliding is happening, all of you write down the question. If A is sliding on B, if A is sliding on B means what? Will they have same acceleration or different? Find the different acceleration. That is the question. So if A is sliding on B, find the acceleration of A and B individually. Done? There's nothing to solve. It's solved here only. You can see the free body diagram solved. What will be the acceleration of A? F minus Fk divided by mass of A. What will be the acceleration of B? F divided by M. So the only difference will be that A will not be A common here. Okay? A you are finding. So A will be this force divided by mass. Here acceleration will be F minus Fk divided by mass. Okay, simple. We move ahead to the next one. So next one, what is happening? This force is getting applied on B. That is a change. So I want you guys to try that. All of you just add the second part. Draw the same figure, but this time apply F on B. And same question. Question is exactly same. Find the force what you should apply so that both of them move together. Solve it quickly.
So in this case, normal reaction is only balancing weight of B.
In which case? Second case.
Yeah, second case.
We'll discuss. You need to see, Aditi, you need to understand that friction is between which two surfaces.
Okay.
Wherever friction is there, you will take that normal.
Okay, fine.
See, if anyone is getting confused which normal to take, you will take the normal between that surface where friction is there. Check. Done. So what have you done? What is this A plus B? Why? What is this MA into 10 you have written? On the right hand side, you have written MA into 10. What is it? Huh? So that is mu. It looks like MA. This looks like mu. What he has written? If I read, I will say MA into 10. So that is mu into A. What is A? Area. Mass. Okay. So mu into N. Okay. On the C, if you just see your calculation, on the right hand side you have written mu into N, correct? Which is force. On the left hand side, what you have written? You have written acceleration. You have equated acceleration with force. There will be mass also there on the left hand side. You missed mass. Okay. Any values for F? So let's discuss it. Let's discuss it. So exactly same thing. The only difference is force is on B now. Let's draw the free body diagram. So I will draw the free body diagram of B first. The mass is, we are taking capital M. This is small m. So force is here. Where will the friction act on B? Left. Now where will the friction act on A? Right. So which force is responsible for moving A along with B? Friction. So this F should be equal to what? Because this is responsible. So we're using the basic definition of force. Force is what? Mass into acceleration. Which acceleration? Common. Because we are assuming that both of them are moving together. That's what is the basis of our calculation. So what is common acceleration? Net force divided by total mass. Clear? Now, this force is moving A along with B. It means there is no sliding. If there is no sliding, this force should be less than Fs max or greater than? Less than. Who said greater? F should be less than Fs max because there is no sliding. So what is F? M small m into acceleration. It should be less than or equal to mu into n. Correct? So you want normal between which two surface? A and B. You want normal between A and B. So whose weight will be getting applied on B? A. So A ka weight will be on B, mg. So what will B do? React by applying which force? Normal force. So what is the normal between A and B? Small mg. This is the calculation. Did you understand what you missed? You only missed mass. That's what I was telling. Yes. What you wrote F divided by m plus m less than or equal to this. So you were equating acceleration with force. You missed mass. Otherwise, your calculation was perfectly correct. So mass gets cancelled. So what will be force? F should be less than or equal to mu g into small m plus capital M. So if you notice the difference in the previous one, here it was capital M or small m? Capital. The difference here is it is small m. That's the only difference. Okay? Some teachers teach this as a shortcut. They say that don't learn this and all. Just write directly this. Okay? But I will not support that. I would want you to know the correct method. It will hardly take 10 more seconds if you are fast. You can visualize things. If you can visualize things, you don't have to draw this. You can imagine this thing that this situation will happen. I have drawn to explain you. Otherwise, you will directly write this and within 2 steps, you will get the answer. 2 steps it will take. So that small is friction force, yes. Because this friction is only moving it. So that's why I'm telling that friction is also a force. Basic definition of force. And the other definition of friction is mu k into n. That's what I mean. Okay. So here I'm not writing this friction as mu k into n. Why? Because I am seeing that this friction is moving it. So mass into common acceleration. Okay. Now one more thing. If you see the inequality, this F is less than or equal to this. So what is the maximum value of this force? This one. All of you know how to read inequality? This force is less than or equal to this. The maximum value will be this. After that, it can be less also. It can be less than also. But maximum you can apply this much. After the moment you exceed, if you exceed this, they will not move together. They will slide. Okay? This is the maximum. Okay, so do practice this. You'll find this type of question in one of your exam. JEE, BITSAT, NEET. Chances are less in KCET or COMET. Chances are less. For KCET, for KCET and COMET, yes, it becomes too easy. But they can ask. Still chances are there, but less. Chalo, let's move ahead. Or any doubts? You guys want to ask anything? Okay. Now, if you want to take it to advanced level, okay, you can add one more block and you can add friction on the ground also. In advance, they say that the ground is not smooth. The ground is also rough. When you draw the free body diagram, you need to show the friction on the ground also. That's the only extra force. Yes, you have to consider this friction on the ground also. It will be F minus this. Okay, take it. Let's move ahead. Done. Write down the heading banking of roads. Click.
Off-road.
Banking of roads. Let's quickly discuss what is banking of why is bank what is the meaning of banking? Huh? Steep. Ghats section. So who came from Kodaikanal just now? Done. So see, If you have seen the racing tracks, have you guys seen any racing tracks? Seen? Where? Not in movies, in reality. Anyone has seen the racing track? Seen where? Noida? Dubai? Dubai? Then where? Bangalore? There is racing track in Bangalore also. Go Go karting is not racing track. If you have not seen, maybe but in movies you would have seen that the racing tracks are a bit tilted on the other side. It's basically not flat. It's basically a bit tilted. So tilted means the road is a bit inclined with respect to the ground. Okay. So if you take this as a horizontal surface, the road will be a bit like this. Okay. So this my palm is basically the road. It is basically tilted with respect to the ground. What is the advantage of that? The moment you tilt the road, that process is called banking. And by the angle which you bank it or tilt it is called banking angle. Okay. Everyone knows what is the formula, but you need to first know what is the advantage. Why the racing tracks you see are banked? The reason is if roads are banked, you don't have to slow down much during the sharp turns. You can still take the sharp turns at a very, very high speed. It is the advantage. But for us, we don't race on the road, right? Okay. Why? Dhruv does it. So let's ignore Dhruv and let's talk about us. So what I'm telling that if we are going on the road, okay, suppose if you are going to a hill station, you would have seen, right? In the Ghat section, you see the curves. So there also the roads are a bit tilted, not same as the racing tracks, but still roads are a bit tilted or banked. What is the advantage? It provides you the required centripetal force for taking the turn safely. It provides you the required centripetal force for taking the turn safely. So for us common man, what is the reason for banking of roads? Safe journey. Wishing us all a safe journey. Okay. So, did you understand the meaning? So, two reasons. First, to avoid accidents. Okay, to avoid accident. Second, to make sure that there is not much wear and tear of the tires. In racing tracks, if you see, if you have noticed any F1 race and all, they change the tire after every 1 or 2 laps. Okay, because there is no problem for money. For us, we can't change the tire every 1 week or 2 weeks because know the price of tires. The costlier the car, the tire ka price is also more. Okay, one tire almost if you have any car of above 15 or 20 lakhs, one tire cost almost 16, 17, 18, 20, 25,000. Okay, so that's why we change the tire after 50,000 kilometers, 60,000 kilometers. So they should design the road in such a way that when you are taking the turn, accident or slipping should not happen. Second thing, the wear and tear of the tire should not happen much. These are the two reasons for banking any road. Clear? So if they ask you a theoretical question, you can answer right why banking is required. Sometimes they don't write to avoid accident. They say to get required centripetal force. That means the same thing. I need enough centripetal force so that I can complete that circular track properly. Both means same. Okay. Any questions? All clear? So if any theory question is there, I hope that you guys can answer it. Now you can see two formulas here on the board. You can see two formulas. If you see the first formula, which looks a bit scary, under root of Rg into mu plus tan theta divided by 1 minus mu tan theta. So this formula are we supposed to remember? Answer is yes. This formula you have to remember. Now, how did we get this formula from this one? If you see, I've written the statement. When the friction between the road and tire is negligible, it means I was going to tell refractive index. It means coefficient of coefficient of friction is how much? Almost zero. Exactly zero, you can't tell. If it is exactly zero, you will slip. Okay? So it is almost zero or very close to zero. So when the friction between the road and the tire is almost zero, why do we need this? To reduce the wear and tear of the tire. Lesser the friction, more will be the life of your tires. Okay? If they write in the question, tell me what is the speed in which the car should take turn to minimize the wear and tear of the tire, which formula will you use? This one or this one? Second one. This one you will use. The moment they use the statement to minimize the wear and tear, it means coefficient of friction is almost zero. The moment you put almost zero, numerator will be what? Tan theta. And denominator will be 1. So Rg tan theta. If they don't mention anything wear and tear, this formula, the moment they say minimize wear and tear, this formula. Make a note quickly. If anybody is interested in knowing the derivation is simple free body diagram on an inclined plane, which is not required now. This is not the right time to learn the derivation. The right time is over. Okay. Grade 11 was the right time. For you all, it was offline, right? Everything 11th, not COVID time. 10th was offline, online. So what do you guys enjoyed more, online or offline? Not online. Don't tell me this. I know that what you have done in online. Okay. In online, very few of you have studied. उसके बाद it was like just attend the call and sleep. Done? Stop it. All of you try this now. All of you read that question. What is written? What is the optimum speed of the race car to avoid wear and tear? So which formula? Under root of Rg tan theta. Coefficient of friction will be almost zero. Tan 15 is given to you, everything. Just substitute, take the square root. R is not given. Circular track, banking level given. Achha, I forgot to write R only. R you can take. What value should I give? Take R as 10. Root 3 is how much? 1.7. So answer will be approximately 5.1 meter per second. Done?
So you just simply give mu's value here, right?
Yeah, mu value is not required. Race is over. Okay. All of you write down the heading impulse. So what is impulse? Change in momentum. Impulse is basically change in momentum. So impulse is change in. Anyone has problem with red color? Change. Impulse is basically change in momentum. Change in momentum is not force. Force is basically the rate of change of momentum. Okay. So change in momentum will be F dt. Okay. F dt. So if you need to find what is the total change in momentum, total change. So what is the mathematical tool for finding total? Integration. Any problem? Any student? So change in momentum will be F dt. So if you want to find total change in momentum, you integrate. So two methods are there. First method, integration of F dt is basically impulse. And integration of F dt gives total change in momentum. So for impulse, you remember only one line, that impulse is same as change in the momentum. The other definition what we see is large force acting for a small interval of time. See here, large force acting for a small interval of time. Okay, what is the example? Cricket. When you see that, what is the time of contact of ball with the bat? Hardly few seconds, millisecond. Can you see the impact? They're able to hit a six of 120 meters, 100 meters. Same thing, you take any sports, badminton, lawn tennis. So what is the time of contact of the tennis ball with the racket? Few milliseconds, but still if you see, sometimes they show the speed of the shot, 145, 150 kilometer per hour. So when a huge force is applied for a small interval of time, the impact what is created, that impact is called impulse. Or we can say that impact is created due to change in momentum. Any doubt? Anyone in the class? So sometimes you will see that they say this impulse is equal to F average into delta t. Okay? And impulse is what? Delta t. Okay? Change in momentum. If it is not average, if it is instantaneous, then what will you use? This. If it is instantaneous. So this is also called impulse. What is the symbol we use for impulse? When would you go for go-karting? Huh? Everything is mixed up, I think, because of go-karting. Mixing all the symbols. What looks like tau? This J is looking like tau. Mutual induction. Mutual induction between U and Dhruv. How come this looks like tau? This is J. Okay. Is it clear? If the force is average and there is a time interval given, delta t means what? Time. Suppose they say the force is acting for 0.3 seconds. There is a time interval. So delta t. Okay. If it is instantaneous, this thing. We say one more thing from here. area under force versus time graph gives what? Impulse. Gives impulse or change in momentum. Do you guys know the reason? Integration of y dx. What is the integration of y dx? Area under y versus x. Remember, application of integral. Any questions? What will be the dimensional formula for impulse? Same as momentum. Because impulse is change in momentum. What is momentum minus momentum? Momentum. Okay. So dimensional formula for impulse will be same as momentum, which is mass into velocity. m1 L1 t to the power minus 1. All clear? Should we move to the next one? We have taken one question also. Solve it. What is the time? All of you draw the figure and write down the question. Where is the chemistry class also after this? Yes? I have to leave you on time. No. Okay, gone. What is the impulse imparted by the wall on the ball? Should we discuss? Anyone who got the answer? We need only 10 seconds to answer this. Huh? Why you got 0? Because you didn't take the direction. We need only 10 seconds to answer this if you know the concept. You don't even write a single step, but fundamental should be clear. Sure, let's discuss it. Students who got 2 MV, very good. 2 MV is the right answer. Anyone who is getting 0, don't change your answer to 2 MV. If you're getting 0, see here, I will explain why you got 0. So the ball is coming and hitting this wall, this point, okay? And it is getting reflected at the same angle with the same magnitude of velocity. Because direction is different. You can see that. Velocity is not same. Magnitude of the velocity is same. So question is, what is the impulse imparted by wall on the ball? First of all, understand the question. When the wall is being hit by this ball will apply some force on this. So what does Newton law says? Ki boss, if you apply a force, you will also receive. So it will apply a force of F on this. Same F force will be applied by wall on the ball also. So both are same. They can ask you, what is the force on the ball by the wall? So answer will be same, but direction will be ulta. Okay. So let's solve it. Take the component. When you take the component, what will be the component of this? MV cos 60. What will be the vertical component? MV sin 60. Anyone in the class having doubt in this taking component? Check. Now, what is the component of this? This is down. So, MV sin 60, correct? And x component will be how much? MV cos 60. All clear? Just observe in the vertical direction. All of you see here. Stop writing. See along the wall. What is the initial momentum along the wall? What is the final momentum along the wall? Is the momentum changing? So what is the impulse? 0. So impulse along the wall is 0 because my initial momentum and final momentum is same. There is no change in the momentum, so no impulse. Now, see perpendicular to the wall. Observe, perpendicular to the wall. What is the initial momentum? mv cos 60. What is the final momentum? Minus mv cos 60. Direction is opposite. Clear? So what will be the change? Final minus initial. So final is minus mv cos 60. Initial is plus or minus? Plus. What is cos 60? 1 by 2. So what will be the answer? Minus mv by 2, correct? Minus mv by 2. What is the answer? Minus. Okay, not 2 mv. Answer is 2 mv cos theta. Okay, answer is 2 mv cos theta. So whatever is theta, you can check, right? It is minus 2 mv cos theta, but magnitude is how much? 2 mv cos theta. Can we do this without writing? Yes, we can. If you can imagine this component ka thing, there is not uh, any requirement to write down this thing. You can directly say minus minus plus, and there is no impulse along the wall. Is the funda clear? Anyone having doubt? Okay. So this is the impulse minus mv. Now, what is the point you learn from here? That there will be no impulse parallel to the surface. This is a point which you learn here. There is no impulse parallel to the reflecting surface. Impulse is always experienced perpendicular to the reflecting surface. Impulse is always experienced perpendicular to the reflecting surface. We will use this statement in the topic called collision. Make a note of this. There is no impulse parallel to the reflecting surface. Impulse is always experienced perpendicular to the reflecting surface. Then we written. Now suppose the time of contact is 0.03 seconds. Time of contact is 0.03 seconds. Find F average. So how will you find? Change in momentum is what? Force into time. Correct? We discussed this just now. F average will be how much? Change in momentum by time. What is change in momentum? mv. What is the answer? mv by 0.05. I have taken the magnitude. Of change in momentum. So if the impulse by the wall on the ball is minus mv, what will be the impulse by the ball on the wall? Plus mv. Okay, so this is the end of the Newton's law of motion. I'll share few questions to practice. You guys can practice in the group. I'll share by tonight for projectile as well as laws of motion. In the next math physics class, we will start work, power, energy. So I want you guys to at least read the fundamentals. What is the formula for work done? What is conservation of mechanical energy? What is work energy theorem? What is the formula for potential energy stored by a spring and gravitational? At least read the basics and come. Okay? Sure. Bye guys. Take care.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Bye bye.